All right, in 4.9, we're going to use isosceles and equilateral triangles. What is an isosceles triangle?
Two-sided.
Two sides are equal, so we have a triangle, and two of the sides are going to be equal. What is an equilateral triangle?
All sides are equal.
All three sides are equal. So the parts of an isosceles triangle. Up here we have the vertex angle, which is this angle at the top. Then the two congruent sides are going to be the legs. So these pink lines here are the legs. So this side is congruent to this one. The angles opposite of the legs are the base angles. So this angle here is the base angle, and this angle here is the base angle, and the base is the bottom side of the triangle. The isosceles triangle theorem states that if two sides of a triangle are congruent, then the angles opposite the sides are congruent. So if segment AB is congruent to segment AC, then angle B is congruent to angle C. So the sides opposite of the angles opposite of the congruent sides are also going to be congruent. So we have angle B is going to be congruent to angle C.
So AB would just be.
The converse of the isosceles triangle theorem states if two angles of the triangle are congruent, then the sides opposite of those angles are congruent. So in this example we have angle B is congruent to angle C, so the sides opposite of these two angles are also going to be congruent. So this is the same as that last example, but the converse of it. Okay, now we're going to do some examples. So let's look at A. It says to find the value of x. How do we find x? We know that this is what type of triangle? Isosceles. So we have two congruent sides, so we know that the angles opposite of those sides are going to be congruent also. So we can call this third angle x. So now, how do we find x?
Equals 100.
So we'll do x plus 30 is equal to 180. Remember, all the angles in the triangle added together equal 180. So we need three angles, add them, and set them equal to 180. So we have 2x plus 30 is equal to 180. We can subtract 30. 2x is equal to 150. And what do we get for x? 75.
What happens if you just have, like, suppose change the third to 75, but you don't have x? Like, there's like no x.
Okay, let's look at B. So we have two congruent angles here. What type of triangle is this? Isosceles. So which sides do we know are going to be congruent? 2x minus 4 is going to be congruent to x plus 5. So how do we set up this equation? Perfect. 2x minus 4 is equal to x plus 5. And now we solve for x. What do we get for x?
9.
9.
You don't have to plug it in, right?
So this just says to find the value of x, so we don't have to plug it in. What if it was asking us for all 3 sides of the triangle?
So you just have to plug in.
Then we would plug it into each side.
Oh, so it's not that bad.
No. Okay, let's look at C. How do we find x here?
Don't you have to add?
So we can let's not call the top angle x because we already have an x there. What else can we call this? The one on top.
Y.
We can call it y. Just anything else. So how do we find y, Mariana?
56 minus 62, or plus 56 plus 62 plus 1.
Is equal to 180. So here we have 118. And what do we get for y? 62. So we can plug 62 back in here. So what type of triangle do we have? Isosceles. Because this angle here is equal to this angle. So what 2 sides do we know are going to be congruent? 42 and x. Because the sides that are opposite of the congruent angles are going to be congruent. So we know that 42 is going to be congruent to x. So what is x? 42.
So wait, how come it wouldn't be 41 and 62? Or 62? It doesn't have to be opposite.
Because we had to find what this angle was in order to tell if it was an isosceles triangle or not. So we found that this angle is 62. So this angle is congruent to this one. So we know that the sides opposite of the congruent angles are going to be congruent. So we know that 42 is going to be congruent to x. So then we can set 42 equal to x. Okay, a corollary to the isosceles triangle theorem states if a triangle is equilateral, then it is equiangular. The corollary to the converse of the isosceles triangle theorem states if a triangle is equiangular, then it is equilateral. Okay, let's do an example. Triangle LKM is equilateral. So what does it mean to be equilateral?
All sides.
All the sides are congruent. So here it has the tick marks on all the sides. If we know that this triangle is equilateral, what do we know about the angles?
That they're all the same.
They're all the same, so it's equiangular too. So if this is an equiangular triangle, what does the measure of each angle have to be? 60. So every single angle in this triangle, all 3 of them, are going to be 60 degrees.
Yeah,
So
to
is it
180.
equilateral or equiangular that they're all 60?
Both.
Oh.
Because if a triangle is equilateral, then it's equiangular.
Oh, so it's to 180.
Right, and they all add up to 180. So if this angle is, because we have to find the value of x. So this angle is 2x plus 32. How do we find x? 2x plus 32 is equal to 60. Now we just solve for x. So we can subtract 32. We get 2x is equal to 28. So x is equal to 14.
Isn't it 19?
14.
4 times 2 is 8, and then 4 times 2 is
Okay, last example. Yay. Find the value of y. Triangle NPO is equiangular. If a triangle is equiangular, then it also has to be?
60.
Well, all the angles
Oh.
are 60 degrees, but if the triangle is equiangular, then what do we know about the sides? That it's equilateral also. So all the sides are what?
60.
Equal. All the sides are equal.
Oh,
Remember, the angles equal 60.
oh yeah. And
But here we're trying to find y, which is y is talking about the sides. So we need to know that all the sides are equal. So how do we find y?
5y minus 6 equals 60.
5y minus 6. We're not dealing with the angles here, so we don't need to know that the angles equal 60.
Equals 4y plus 2.
Equals 4y plus 12. Because we said that this side here is equal to this side.
So how come we wouldn't put it to equal to 60?
Because we're not trying to find the measure of the angles right now.
Oh.
These measurements that it's giving us is talking about the sides.
I thought equiangular had to do with angles.
Well, equiangular has to do with angles, but in 4.9, we learned that if a triangle is equiangular, then it also has to be equilateral. So we're applying that corollary now. So now we solve for y. 18? What's the question asking us? Just to find the value of y.
And then for equilateral, you are trying to find the angles because if it's